Welcome to the Linux TV. My name is Penn. Today we dive deep into the world of Linux permissions, file access, in all Linux operating systems. Let's start with the basics. In Linux, every file and directory has permissions: read, write, and execute, assigned to three categories: the owner, the group, and everyone else. This system has worked well for decades, but what happens when you need something more specific? What if you want to give a single user write access to a file without changing the owner or group? That's where ACLs come in. ACL stands for Access Control List, and it lets you set permissions for individual users or groups on a per-file basis, going beyond the traditional owner-group-other model. So why do we need ACLs? The traditional permission model has a big limitation. You can only assign one owner and one group to a file. If you have a file that needs to be accessible by users from different groups, or if you want to give a specific user different permissions than their group, you're stuck. ACLs solve this by letting you add multiple permission entries to a single file. You can grant read access to the marketing team, write access to a specific developer, and execute permissions to a particular manager. All on the same file, all at the same time. Now let's look at how to view ACLs. The command is simple: getfacl followed by the file name. When you run getfacl on a file, you'll see the traditional permissions listed as user, group, and other. But you'll also see any additional ACL entries. These entries show specific users or groups with their own permission sets. If a file has ACLs applied, you'll also notice a plus sign at the end of the permission string when you run ls-l. That plus sign is your quick indicator that ACLs are in effect. To set an ACL, we use the setfacl command. The syntax is straightforward. To grant a user named John read and write access to a file, you'd type setfacl-m u:john:_rw file name. The -m flag means modify. The U stands for user, followed by the username and the permissions you want to grant. You can also set ACLs for groups using G instead of U. For example, setfacl-mg:developers:_rwx project-folder gives the developers group full access. Let's walk through a real-world example. Imagine you have a shared project directory. The owner is Alice, and the group is engineering. But you also have a contractor named Bob who needs read access to specific files, and a QA team that needs write access to the test results folder. With traditional permissions, this would be a mess. With ACLs, it's clean. You'd run setfacl-m u:"bob:"r on the files Bob needs to read, and setfacl-m gqa:"rw on the test results directory. Each user and group gets exactly the access they need, no more, no less. What if you need to remove an ACL entry? That's where the -x flag comes in. To remove John's access from a file, you'd run setfacl-xu:"John file name. This removes just that specific ACL entry without affecting other permissions. If you want to remove all ACLs from a file and restore the traditional permission model, use setfacl-b file name. The -b flag strips all ACL entries, returning the file to its original state. Finally, let's talk about default ACLs. Default ACLs are applied to directories, and they automatically apply to any new file or subdirectory created inside that directory. This is incredibly useful for shared folders where you want consistent permissions. To set a default ACL, use the -d flag. Set facl-d-m g developers rwx shared folder. Now every new file created in that folder will automatically have the developers group with read, write, and execute permissions. And there you have it. ACLs give you fine-grained control over file permissions in Linux, letting you go beyond the traditional owner-group-other model. You can view them with getfacl, set them with setfacl, remove them when needed, and set defaults on directories for consistent permissions across new files. If you found this helpful, hit subscribe for more Linux tutorials. This is Penn from the Linux TV, and I'll see you in the next one.